digital part. Okay, what we have discussed so far is only the number systems, how the numbers are manipulated in computers and all. A very simple thing. Now we are all convinced that we are going to deal with binary numbers just because they are simple to represent, manipulate, and all the electronic devices can be well in fast form, in small and compact form, can deal with the binary arithmetic. See, this binary arithmetic and binary number representation is not new. It goes back to the 18th century when the first the scientists discovered that okay, this can be the numbers can be represented in various forms, and binary may give some advantages there. But first of all, it was observed by Boole, George Boole, and what he did was he represented the human thoughts or the thought process, okay, using these binary numbers. Say for example, I want to go, okay, so I'll represent it with 1. I don't want to go, I'll represent at 0. I'll continue with the lecture, I'll represent at 1. I don't want to continue, it is represented at 0. But what about the other things? I mean, say for example, if I need to continue with the lecture only if I'm having an extra energy. So what I will do that, say for example, I'm having, so now let me put these thoughts, okay, let me put these thoughts in some mathematical representation. Say for example, there is a function which says that I will continue with the lecture only if I'm having an extra energy x. So this, okay, so this will be 1 only if the x will be there. So this function will be true, okay, this will be valid, or will be, I will continue with the lecture. That means lecture continuation will be denoted by 1, no, it will be denoted as 0. If I am having extra energy is represented as 1. If I don't have extra energy, I will represent it as 0. But f of x represent continuation of lecture, x represent the energy. So if I am having an energy, f of x will be x itself, that means 1. Continue the lecture. If I don't have extra energy, f of x will be, but say for example, I need to continue with the lecture no matter I am having energy or not, okay, I just need to complete the syllabus, okay. So what I will do, I mean, doesn't matter it's x, so so I will represent this f of x, I will always continue 1, doesn't matter it is x, okay. So what is this? I'm having some thought process, okay, I'm having some events which is there in my mind, okay, human events. I have simply represented those events with some variables x, y, a, b, c, and I have done some, have defined some kind of rules for that, okay. Those rules, now whatever the rules and the representations are known as, the first was, it was represented by Boole, George Boole, or whatever you want to say, long back in 18th century, 1840s, okay, and he came up with a nice paper. So homework for you is to find that paper, okay, the old paper by Boole, okay, the representation of thoughts, I think something like that, I don't know what's with me. Just find out that paper, so very old one, I don't have right now the title of that paper. Alright, so yeah, an investigation of laws of thoughts, so that was the paper in 1954. So in 1854. So the paper was an investigation of laws of thoughts. So he just represented those things in mathematical form, okay, and but it was around 100 years later, okay, when Claude Shannon, okay, Shannon is very big figure, big shot, okay, you'll hear his name all the while during your classes, okay. If you're going for DSP, if you're going for communication subjects, you are going to hear his name, okay, Shannon, Claude Shannon. What he realized was, he came up with another theory of representing the electrical instruments, okay, electrical devices or the switches using this Boole's algebra, okay. Whatever the manipulations, whatever the representation he did was again recalled in the 19th century by Claude Shannon. What he did was, using the this Boole's algebra, Boolean algebra, is simply represented those things with relays and switches, with all the electronic, all electrical devices. Okay, say for example, okay, if I'm having some push button there, it's input and output. This is an electronic switch. If I simply push this, okay, so let's say it is X, the current will flow, the output will be there. So if X is 1, the Y is 1, okay, I mean the output is 1, is Y. And if X is 0, the output is 0, that means no output. So this is simply push button. Okay, I can simply represent it with a switch. It need not be. Okay, I can simply represent it with switch, something like this. When I push, it will disconnect. When I assume that there is a spring there, if I simply remove it, it will again connect. So what is that? If the X is not there, that means I am not doing pushing operation. Then the output will be 1. If X is there, output will be 0. This is an inversion operation. This can be considered as inverter. So what I did was, this is push button switch. Assume that there is spring. Only if I push, this will disconnect. Otherwise, it will release and join. So if I am not giving any X, it is already connected. Not giving any X, it's already connected, and Y is 1. If I am pushing, it will disconnect, and the output won't be. See, this is what Shannon did. Shannon, what he did? He simply represented. Earlier, जब इन्होंने जब ये investigation of thoughts दिया था, the people were not knowing that will be more that successful theory. It was only theoretical. When the Shannon represented those things in electrical sense, then they found that it may have potential application, and that's what the advantage we are getting today. All the electronic devices actually work as a switch. Okay, can you give, based on your the previous course of analog electronics, can you give me a simple example of a switch based on what you have learned in the analog electronics? It's like a simple diode that acts as a switch. Okay, what if I without using diode I need to operate a switch, and also I need an amplification. If I need an amplification, also it should act as a switch. Or say for example, I don't need to act as, I simply want to act with something like this, an inverter, a transistor, but in what configuration? You have forgotten everything about. Okay, ट्रांजिस्टर एक डिवाइस पढ़ा था हमने, उसके कितने सारे कॉन्फ़िगरेशंस थे? कॉमन बेस, कॉमन एमिटर, कॉमन कलेक्टर. In the I wasn't expecting this from you, Divesh. I will beat you. There were 3 different configurations. The output was inverted in what configuration? मारूंगा मैं आपको. Yes, it's common emitter. In common emitter, you see that. Okay. यार कैसे हो यार? पूरी मेहनत पानी में. देखो, ये जब ऐसा ऑपरेशन था, input if you give like this, the output will be like this, 180 degree phase shift in common emitter. That's why minus sign is there, minus A, minus GMRD, minus the voltage gain, current gain, सब भूल गए क्या? So this is a transistor. Why it was minus sign? Now it is common emitter. There, if I am taking the output from here, as this increases, the voltage increases, what will happen? This will turn on this. Okay, more IB, more IC. Okay, but if it more IC, there is a resistor there. Okay, this will get connected. Okay, this will get connected, and the output will be shorted, right? I mean, the path will be at 0. That means it will be. See, what is the output voltage here? What is the output voltage here? I mean, whatever the main voltage, VTCC or VDD, minus this voltage, that will get there. Okay, more the current, more will the voltage drop. Okay, more will the voltage drop here, and very less will be appearing here. So more is the current, very less drop, that means very less voltage will appear here, and so on. But if it is less voltage drop, it will more voltage at the output. In that sense, it's a inversion operation, right? So simplest case was electronic. So all these devices, electronic devices, okay, in simplest form may act as a this kind of switches, okay, or an inverter operation. So okay, this was all what you have learned last time. So let me rub this. Uh, all right. So point to take is the thought process. We are represented in some mathematical form. Okay, then they are having some rules. Okay, so that's what is known as Boolean rules. Okay, say for example. Uh, okay, so there are only three basic rules while doing all this, logical. Now I'm using the word logic. These are all my logical thoughts, okay, or thought process. I'm representing it in mathematical expression of form. Now, to deal with these variables, say for example, I have dealt with only one variable here. I may deal with multiple variables. Say for example, it is only my thought process. Say for example, if class interest is taken into account, okay, then I will have two variables. I am not going to continue unless until your the class is interested. I may continue, not continue, it all depends on me. I can simply ignore your things. So see, what is happening? I am now relating the two variables. There is another variable which is coming into picture. Yeah. So how to now? If you need to deal with these thought processes, if you need to deal with these two variables or various logical. Now these are all logical thoughts. There are some predefined rules there. There are some predefined rules, or what is called as axioms, or operations, you can say. Okay, there are three basic operations in. Now let me write that. It's a Boolean algebra. The three basic operations are, first one is the AND operation. The AND operation is represented, okay, now my thought process is there, okay, my thought process is, say for example, now AND operation is represented using this symbol. This is known as AND operation or AND gate. They are saying that gate, say it as a gate. I'll tell you why it is called as gate and so. So say for example, I am having two inputs. It may have multiple inputs, but it will always have one output. Okay, it may not have multiple outputs. That doesn't have any meaning. Okay, so if I am saying something, if the instructor is there, I, and if the class interest is also there, okay, the class I, C. If both are interested, then only class will happen. Otherwise, not. So there are two variables involved. Okay, my interest and also the class interest. If your people are not ready to listen, what I will do, right? I mean, the output will be always zero. I mean, class won't happen. Nice form, ideally. So there are two variables involved. Not necessarily it may have two variables. It may have multiple variables and number of variables. In general, so let me grab this. In general, this thought process is given this such kind of symbol with multiple inputs and one output. It's called gate, so let me write it X. So let it A, B, and up to any number N, and let it be output. So output is true. I mean, the class would happen. Output is true only if all these conditions are satisfied. All of them are true. It's called gate just because gate would open. Okay, this will be true. The gate will be open for yes only if all the inputs are present. Okay, so let me write that. So gate opens. That means output is true. Only if all inputs are true. Now, what am true, false? What is that? So, as I said, binary numbers can be represented as 0 and 1s. Okay. As I said, 0 and 1 need not be 0 and 5 volts. Okay. The labeling of zeros and ones or is up to us, okay, on the electronic components. So it may be called as low or high. It may be called as the false or true. So this is all the same. Whenever I say true, it's 1, or it may be, See, all these electronic devices, we say it as 0 and 5 volts. As the technology is going, okay, technology is proceeding, this 5 volts is no more 5 volts. We are all targeting to reduce the power. So it's now 3.5 volts, even at 1.5 volts. The CMOS technology is having the advantage of dealing with, in working with such a small power. Come voltage, come power, come current, come power dissipation, and still your electronic devices works flawlessly. Alright, so this is one operation. Now an example would be, as I've given in the class, if both are interested then only it will be one, or otherwise you may go for, if you want to go for a movie, only if your both the friends are there, okay, so if both the friends are present then only you go for the movie and so on. Yeah, we have another example. Second one is OR. So OR, that thought, okay, the way of representation is represented with symbol something like this. See, the symbol doesn't mean that we have an electronic devices which looks like this. Its photograph is like this. No, this is a graphical representation or symbolic representation of those thought process. Again, it may have multiple inputs. A, B, Y there. Here the output is 1 or true or high. If at least one input is true or present. Same example, you people are there, and I'll teach the class, at least one student should be there. If no one is there, if I'm blabbering something, people will find out something like pagal ho gaya. Yeah. So I will go for the class, lecture will happen only if at least one student should be there. Okay, so that's the thought process. I'm simply representing those thought process with the OR. Okay. I've given the example. You will find another one. You may go for movie. Doesn't matter. Any one of your friend comes. If I need to go for movie, I'll go. Okay. So something like that. The third one. It's not, or an inversion operation. So it is represented using this symbol. It doesn't mean that the electronic devices looks like this, just a way of representation. Okay? X there, the Y will be X. What is called, now I am representing this using this notation. See here, notation would be prime, or an apostrophe there, or over bar, okay, head bar there. Yeah. So now this is somewhat complement. Okay, so can you give me some example? Real life example. Inversion. Come on. Huh? Okay. Oh my God. So that's wait. No. That is capturing something really beneficial. It was good that you gave that example. First of all, invert is having only one input. Different is gone. Okay. So that is giving some insight. Invert is having only one input, not multiple. Have I drawn any multiple inputs? मेरी भी गलती है क्या उसमें? तो मुझसे सिर्फ एक ही इनपुट रहेगा, एक को ही वन. So it's inversion operation. Now tell me. I'll give some example. Huh? Food is not good. Yeah. Food. Okay. I mean, food is not good. Still, you will go to hostel. No. You'll go outside if the hostel food is not. Okay. So X is hostel food, and Y is the outside food. Okay. Go for hostel food. Huh? Even if it is bad, huh? How? Why? It saves food. Okay, so I'm having a good proposal for all of you. So it is a lot of things are happening in the hostel. Okay, I'm aware. You don't know that I'm not aware. Yeah. No, you don't need to put inverter there. Okay, what you can do is, let's come up with a system. You are computer science students. Let's come up with a system. Okay, nice system or an app. All of you are having smart devices with you. After opening that app, it should connect it to the internet or any. All you are having Geo. Okay, free. Everything is free. So it should have four options. Say for example, I woke up in the morning. If I need to go in breakfast, we can't avoid that. But once we are done with the breakfast, there should be some reminder on your phone saying that at 9 o'clock, why you will be there for the lunch. If it is there, say yes or no. If you won't be there, say no. Okay. In that sense, the caterer would come to know how many people are going to be there for the lunch. Once you are done with the lunch, go for the snacks. The same thing. Okay, snacks में भी ज़्यादा saving नहीं होता, but you can repeat the same procedure for the dinner time. In that sense, he will come to know how many people are going to eat. मतलब उसका भी नुकसान नहीं, अपना भी नुकसान नहीं. In that sense, that will solve your problem. I mean, food won't go waste, still will remain healthy. Yeah. Yeah. हाँ? So that's what I'm saying. तो टेस्टी बनेगा ये अपने को जाके पहले खाना पड़ेगा ना, फिर पता चलेगा. Isn't it? हाँ? पहले सेमेस्टर वही खाया. See, this hostel is always a. If you are facing problem, you should always give a feedback such that it should show that you are really facing problem.
We are given feedback. We have written a letter. Now they are saying that letter mein English is not good, so we won't accept it. Now this is such a silly reason.
Okay, so these kind of things you should discuss with the office, isn't it? I mean, if I see, if I am intervening in that, people say that I am there. I mean, I want nice food for that. You know, see, I don't matter. It doesn't matter to me. I mean, I can eat there, I can eat anywhere. So I'm just worried about it. I'm just a convener there. But still, people are like, they may ask me, okay, why you are interested in that? So it should reflect that no, we don't want that. Yeah, we are all concerned about our health. It doesn't matter. I mean, if it is 85 rupees, 90 rupees, I'm ready to pay 10 rupees more. Okay, I mean, 100 rupees, if it 3,000 rupees, if you go for per month, I can understand your financial conditions. Okay, people. But if you are खाना अगर अच्छा रहा है, जो पेट के अंदर जाता है वो अगर अच्छा रहा, तभी हम अच्छे से काम कर सकते हैं. ओके, द फूड इनसाइड व्हाटएवर इज टेकिंग इनसाइड इफ इट्स नॉट गुड एंड हेल्दी, यू कांट डू एनीथिंग. ओके, दैट शुड नॉट, मतलब उसके बारे में कोई कॉम्प्रोमाइज नहीं. खाने के बारे में तो कोई कॉम्प्रोमाइज नहीं. हाँ, ऑफ कोर्स इट शुड बी अफोर्डेबल. दैट इज द पॉइंट. इट शुड बी अफोर्डेबल. इसका मतलब ये नहीं कि 50 रुपये में वो अच्छा नहीं बना सकता. उसको मैनेजमेंट ही तो करना है ना. मतलब तू कम सब्जी दे, कम दे, पर अच्छे से तो बना. सो दैट्स वो उसका स्किल. वो अगर नहीं दिखता तो बताओ. इसका मतलब ये नहीं कि मतलब कम पैसे इसलिए मैं अच्छा नहीं बनूंगा. तो बहुत ही हो गया उसका. तो मतलब कम पैसे है ना, कम आइटम बना, अच्छे बना. दैट्स हिज स्किल. सो ओके, दिस नॉट अबाउट मैथ्स. ओके, मैंने कुछ नहीं कहा यहाँ पे, सब भूल जाओ. सो ये सब व्हाट आई एम सेइंग इज ओनली 3 ऑपरेशंस आर देयर. इज नोन एज बुलियन लॉजिकल अलजेब्रा. ओके, सो लेट मी पुट ऑल दिस टेबल्स. ओके, ऑल लेट मी समराइज ऑल दिस थिंग्स फॉर 2 वेरिएबल्स. X there. So this operation and is represented by this x dot y or x and y. Okay, or it may have some multiple forms also. You may represent with this with that, and so on. But we're going to or simply you may represent it with xy. Can simply remove that dot. So I'll simply I'll simply represent it with x dot y. Yeah. So 4 combinations. I'm taking quite slowly. Okay. So yeah, and the output is true only if all. Okay, दो है इसलिए ठीक है. All. Okay, only if all the inputs are true. So it's 1 here, otherwise all 0. Or operation is denoted by plus sign there. Okay, there are multiple representations, but we'll go for this. Or is at least 1 should be there. So at least 1 there. At least 1. एटलीस्ट वन, कम से कम एक बंदा तो आएगा, दो बंदे अगर पढ़ाऊंगा नहीं मैं. हाँ, so you got me. All right. Okay, सब बच्चे सुनो. These operations are logical operations, not arithmetic operations. Okay, so x plus y arithmetic is not same as x plus y logical. X plus y in arithmetic, 1 plus 1 is 0 there and 1 carry there. But no. In OR, although we represent by the same sign, it represents or no, either operation. So what we are dealing now, nice one, I'll give you a chocolate for that. But this, you should raise such questions because since logical and arithmetic operations are different. Okay, you should always remember, and that's the difference. See, you remember in the last class I said that whenever I am writing plus sign, you should first ask it is logical or arithmetic. There I have marked it and said that it's arithmetic. Okay, here it's logical. Okay, but from the problem, if sometimes I don't mention, you should have logic that you should interpret as logical or arithmetic. It's up to you. And I mean, you should have उतना तो सोच ही सकते हो प्रॉब्लम के हिसाब से अरिथमेटिक. इफ यू आर हैविंग डाउट्स यू कैन आस्क. Alright, yeah. So it's not, well, in not operation you don't have two variables, only have one variable. That's why I won't write it. It will be, if it is 0, it will be 1. If it is 1, it will be 0. That's it. Alright, so is that clear? Your doubt? Yeah. So this is different. These two are different. So go back to your hostel, ask your friends that what is 1 plus 1 in binary. Okay, if they give wrong answer, you just laugh and say that I didn't ask is it logical or arithmetic. So in that sense. Alright, that is fine. Alright, we'll come to the main point. Hope you guys are not tired. I know that, but let's see. Okay, Boolean algebra, we are taking some input, we are doing some operations there, we are getting some output. Those operations are not limited to the 3, 1, 3, those are the basic operations, but the output may not be only dependent on those 3 operations. Say for example, I'll give the same example. Okay, x, y, not y, let me take 2 variables, a, b there, output, let's say a movie. My 2 friends are there, nice friends. I'll go for movie. Okay, it may happen that if both are there, if I am there, I may alone go for movie. It doesn't matter my friend comes or not. If I am a nice person, I'll wait for my friend and then I will go for movie. Movie wala doesn't know that if you come or not, I'll play the movie. So how many possibilities are there? See, the M may be 1 depending on many thought process. It may be always 1. Doesn't matter you come or not. Okay, in flag hosting on 15th of August or 26th January, doesn't matter you come or not, the flag will host. Same with the movie. Okay, so even if your friend, it may happen that only if your friend comes, then only I will play the movie. Say for example, my true friend is one among yourself. Okay, if 2 people are there and one of my best friend is not in, I didn't play karte, kal karte, wo nahi hai. So what I'm saying is the output may be depend on several thought process. Okay, it need not be and or not operation. It may have several such combinations. Now I am giving you, right now class workout example. Okay, say for example there are 2 variables. Come up with how many possibilities it would be for output would be true. Okay, how many logical process they may be. Okay, say for example M may be 1, doesn't matter someone comes or not. M may be 0, doesn't matter whosoever comes. Minister भी नहीं, मेरी घर की टॉकी से मैं प्ले नहीं करता हूँ, मैं नहीं करूँगा प्ले, नहीं जाओ तुम, मैं नहीं करूँगा. तो मतलब how many such possibilities would be there? How many such possibilities would be there if 2 variables are involved? Can you work it out? Okay. So think yourself as a minister or friend. Okay, work out how many possibilities. Work it out. Yes, what would it be? 4 possibilities. How many are you only 4 possibilities? What are the 4 possibilities there? I'm asking that. Forget about this. Okay, I mean, A and B are some two variables there. What are the possibilities on? I mean, what set of rules? How many possible set of rules can be implemented or imposed on A and B, such that output may be one or zero? So, for example, some blank faces. For example, so there are only four. 0, 1, 1, 0, 1, 1. Okay, two four possibilities. I may play movie, doesn't matter who comes or not. 1, 1, 1, 1. I may not play movie, doesn't matter who comes. Only minister also comes, doesn't matter. I may play movie only if A is there. A is come, A came. Okay. So, how many possibilities are there? There's 16 such logical processes only for two variables. So always remember those number of logical operations. Let me write that now. Can you generalize those things for two variables or for n variables? Binary, no? Binary variables. Binary would be this one. Is it okay? So let's see all of them. Let's see all of them. So the output, let me denote it by f function, f0. It may be 0, doesn't matter who comes or not, so it is called as null operation. Output f1 may be 1, it is known as identity operation. The output maybe only x, only if 1 is there. Okay, so it is known as transfer operation. And I may be so cruel that if the front doesn't come, then only I will play the move. Okay, so it may be f3 only if doesn't come. This is called as inversion or complement. F4, it may be I'll play the movie if he doesn't come, only if he comes, the other friend comes, only I can play the movie. So that's another possibility. Again, it's called transfer. I'm mentioning all the possibilities for two variables. Yeah. F5, only if that he doesn't comes, okay, the other friend doesn't comes. Inversion or complement again. I'm so kind that I'll play the movie only if both of them comes. So it's an AND operation. I'll play the movie only if both of them doesn't come. So it's a what is called as NAND operation, not of AND. The theater wala is himself interested in playing the movie. So either of it comes, okay, can play the movie. At least he needs one companion for that. So OR operation, F9, maybe this one is NOR operation. Visit, I'll write it here. F10, X. If you came but your friend doesn't come, then only I can play the movie. So it's called as inhibition. All English words. I know the meaning, homework for you. You increase your vocabulary. Again the same. F12. Implication. Just for reference, so that anytime if you get stuck somewhere, this will help you out. Any other combination if you let me write all these things first. For B, X, Y bar, exclusive OR. Say for example, can you give me some example? If in a movie theater only one seat is there, two people are going. If you come, you should not come. The other should come. The first should not come. It's an exclusive OR operation. I mean, if the first friend is present, other should be absent, or this first one is not present, the other should be present. Something. Why? Can you give me an example for this? I mean, good example. Exclusive. एक तो दोनों आओ ना तुम मत आओ मतलब आई एम से फॉर एग्जांपल झगड़ा हुआ है दो लोगों के बीच में और मैं बुलाता हूँ अगर एक बंदा आएगा तो वो तो झूठ बोलेगा ना दूसरे बारे में दोनों आओ ना तो दोनों मत आओ like that you have your own thought process so you may expect those thought processes in your exams. I will give some examples. Okay, you need to form or come out of such kind of expressions. All right. So just a small and last topic, just because it will be. No. Oh, okay. So these are the all other. If you come up with other possibilities, it will be one among them. If you reduce the expression, it will be one among them. Yeah. So there are some set of now we are having some thoughts we have represented in nice variable mathematical form. When you deal with those, when I'm saying that and or not operation, when you deal with multiple such variables, okay, there are some predefined set of rules, okay, which are found to be correct. Those are known as axioms or some properties of Boolean algebra. Let me write those things. It's a very important thing, and that also will be your first lab. So let me put that axioms of Boolean algebra. Axioms are nothing but properties, okay, some set of rules which are in some sense true or practically found out to be true. So again I am saying, okay, let me repeat, okay, this is logical thing, okay, logical operations we are dealing with, okay, and it is very interesting to know that these logical circuits will try to build up arithmetic circuits, okay. We'll come to know that these logical circuits will help us to implement the arithmetic operations. Say for example, I want to add arithmetically 10 plus 12 with the logical circuits we are going to set of rules. So first one 0.0, that's means AND operation. 0. It's not difficult to remember these things, more or less like an arithmetic operation. It's 0, that is also equal to 1 into 0. 3. 0 or 0, it's nothing but 0. 4. 0 or 1, that is equal to 1 or 0, but 1. If x is 0, x bar is 1. If x is 1, x bar is 0. This is a set of rules. If there is one variable x, if I multiply with 0, it will be 0. If I am having x, to multiply with 1, it will be x, not 1. or 1, tell me. हाँ 1 doesn't matter, I mean ये आया नहीं आया मैं मूवी प्ले करने वाला हूँ, 1 something like that. Something 0 1, yeah, x into x square, x or x then x into x bar is 0. Okay. 13. Oops. X or 1. X bar का bar into x. 3 x into y, nothing but y into x. That's commutative property. 16 x or y is equals to y or x. So these are nothing but commutative properties. Not, this is not a minus sign, this is not yes, correct. Z same thing with the plus sign. X is called as associative property. Yeah? Yes, you are right. So into y plus z, so x into y, x into z. Distribute you. Okay, so into plus y into z, so x plus y whole thing multiplied by plus z. There are some interesting properties. So these are distributive properties. These now there are some interesting properties. Absorption, x plus x into y these are the one which we are going to exclude, we are going to use rigorously. Not this, but the another one, this one and the other one. X absorption. absorption. Okay, so if you have written, better you should note this, okay, at one place. I'll also ask TAs to take a print and display it on the flag. This is the one which we are going to use very rigorously. Is x into y plus x into y bar. 24 x plus y into x of y bar, and again x x into y. Now see, as I said, these are the most important properties that we are going to deal, okay, in the subsequent section. These are known as combining properties, combination properties. Y bar is equals to x bar plus y bar, x plus y bar equals to y dash. These are known as De Morgan's theorem. X, now I'm going to do with 3 variables. Okay, let me write these things first. Into y, y, into x into x, x plus y, x dot y. So always remember that if this is changing, okay, you just need to retain x and y. X into, now this we'll rarely use, okay. So remember this, I need to I'm just putting it just for the sake of completeness. Z. These are 3 variable properties. This should be sufficient to deal with multiple variables. X plus y, y into y plus z, and x bar plus z. Don't need to worry, okay, don't need to remember these things. You can always deduce your expressions if you simply know earlier laws. So these are known as consensus properties. हेलो, हाँ नहीं, हाँ यार है। ठीक है, अभी ये यहाँ पे है ना 200, मैं आ ही रहा हूँ, बस 5 मिनट लगेंगे। Alright, so you don't need to remember all this, okay. If you are simply ये पहले फर्स्ट 2 वेरिएबल्स की प्रॉपर्टीज भी आपको आ गई ना, ये वाली, इतना सारा रिमेंबर करना नहीं, ये सिंपल है, ओके, ना कुछ नहीं है, नथिंग। ओके, सो yeah, the most important thing is in code, most important thing is the priorities. The priorities in Boolean algebra are first the parenthesis. I mean priorities. First is the parenthesis. What do you mean by parenthesis? Brackets. Yeah. Actually, bracket is not the. What is bracket? Okay, you tell me what is this? Wrong. What is this? Wrong. What is this? Okay, the correct name is, this is called as bracket. This is parenthesis. Braces. Okay, should be. मैं यहाँ पे नागपुर में यशवंत कॉलेज का लेटेस्ट वाला उसने क्लासेस कर रहा था मैं, तो He's always very fond of, and when I'm saying, oh, this is curly or floor bracket, this is a round bracket, this is a square bracket or brick wall bracket. No, it's like, no. Use the terms nicely. This is bracket, this is a brace, this is a parenthesis. You won't use those three different terms for brackets. Parenthesis, then and. I think it should be, before that it should be not, no? Not operation should be done first. Not, then and not. Okay, I mean, this comes is similar to your arithmetic operations. Yeah? So first of all, okay, some things. You'll have a lab today. First of all, you have a lab today. Batch. Who? Which batch is there now today? So yes, you are going to have lab today. Yeah. So in lab, क्या होता था पहले? Analog electronics में let's stop here first. पहले क्या होता था? Theory में portion हुआ नहीं हुआ, lab में तो चलते रहेगा. Just avoid those crap things, okay? Just because lab is under me right now, at least for you people, we'll go for the lab only. Okay? As you know, certain things are not pestering me so that I should conduct the labs. But this theory is done, okay? Today we'll have a simple, gates and Boolean expression verification in your lab, okay? So first let me